Greet, Greetings everyone. This is our design to achieve the goal. So here there will be two entities, the teacher and the student. The teacher will have access to the subject that they are teaching, the materials they are teaching, and they will have daily quizzes that they can ask the student at the classroom to get better understanding of what the students are, how the students are performing, and teacher can have access to the performance of individual students as well, and as well as the whole class as the whole class. And then again, the teacher will get personalized content based on the review from the teacher, and also by understanding each and a individual student, we will give teacher uh, personalized content which 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 will be helpful to teacher to teach in a better way than in a traditional way. So we will have this understanding uh, by performing lot of quizzes to a student. So here student will have multiple subjects. For each subject, they will have to write some quizzes. These quizzes will then be analyzed using cognitive diagnostic models, and then again with those diagnostic results, we will improve the quality of content creation. We will analyze the student and then improve the quality of content creation. So then the student will get personalized content. So the database that we are using is qtrain database for multimodal as a multimodal vector database, and then Postgres as just a relational database to store basic information of teacher and student and all those relationships. So here we are using Llama 3 from the inference provider Grok. So how do we achieve personalization? This is the process. So take an example of a section, like a section from a textbook like photosynthesis. For that section, we will query the database, get the section from the database. This is the actual textbook database, and then again, we believe that the textbooks are good, but they are not great enough. So we will take some inspiration from YouTube articles and blogs. We will create a multi-model vector database, and that will be the quadrant database. So here, before moving on to that, student will like as I said, student will have performed quizzes. So with those quizzes, we will get student traits like the areas that we should improve the student. So with that traits in mind, we will let LLM to query the database and get personalized content from YouTube videos and articles. And then with those additional resources as well as the textbook, we will send the traits, the textbook content, and the additional content to a multimodal LLM. So here again we are using Llama, and then it will generate a personalized content for the student based on the traits that the student already has. And then again, how are we achieving the quizzes that we are putting to the student? These quizzes are also very personalized. They are very distinguishable between every student. So this is actually done by using. So here you could see uh, at the beginning we have to collect massive amounts of questions from the textbooks, the older textbooks and previous year question papers, and all of those. There we will have 10 levels of difficulty from 0.1 to 1. Each question will be categorized between these levels, and then again at the initial level, every student has we will record some skills that we think is essential to understand a student performance. So these some of skills will be there. So at the beginning, every skill should have equal weights. So here every student will have equal opportunity to get a difficulty level of same. So at the beginning, the questions will be at the same difficulty level for every student. As the student takes quizzes, the diagnostic model analyzes the student, and tells us where the student has to improve himself. So based on that, we will improve the difficulty level here. as you can see, the probability of selecting every skill will change. So based on these skills level, we will pick the questions from this collection of clusters between the difficulty level from 0.1 to 1. So this is the entire approach that we are uh, following.